Hi, welcome everybody. Today's lesson is on solving molarity problems when you're given molarity. So, what happens when you're given molarity in a problem? Let's say you're solving a problem and the molarity is given to you or known. So, somewhere in the problem it might say you have a 0.20 molar sodium hydroxide solution and would have the capital M, meaning molar. Or sometimes it might even use the word molar. You have a 3.00 molar HCl solution. So what do you do when you're given that information? Well, you need to remember that capital M or the word molar or the word molarity means moles per liter. Moles per liter, and that's actually 2 units. So when I think about molar, I actually have to, and I recommend actually writing this down, I have to think not as 0.20 capital M, I have to think that really means 0.20 moles of sodium hydroxide equals 1 liter. So capital M means moles per liter, which means that's actually a conversion factor or a fraction. If it says something like 3.00 molar, that's using the word instead of the capital M. I also want to change that to 3.00 moles of HCl equals 1 liter. So when you see these units, they are not 1 unit. They are actually 2 units, which makes them a conversion factor. So go ahead when you have a problem with molar or capital M, both molar, change it to the equivalence, 0.20 moles of sodium hydroxide equals 1 liter, or 3.00 moles of HCl equals 1 liter, and use that as a conversion factor. So when you use it as a conversion factor in the middle of a unit analysis problem, you may write the fraction with the 0.2 moles of sodium hydroxide on the top and the liter on the bottom, or you may end up writing the conversion factor with the liters on the top and the moles on the bottom, depending on what units you need to get rid of and what units you want. So what about solving a problem? So we've given you the first hint, and that is that capital M or molar is actually 2 units, and you need to rewrite it as 2 units. And another hint is don't start with molarity. We've talked about this before, that you don't start with the conversion factor. Unless you want to end with a fraction, then you start with a fraction, but not today. So we're not going to be starting with molarity. So let's actually do a problem so you can see it all the way through. Here's the first example. How many grams of sodium hydroxide are needed to make 100.0 milliliters of 0.20 molar sodium hydroxide? So the first thing you want to do is remember that this is actually a conversion factor. So I'm going to change that to 0.20 moles of sodium hydroxide equals 1 liter. So I'm going to change that and remind myself that that's actually a conversion factor or an equivalence. So now I'm going to solve the problem as I normally do. And the first thing to solve a problem is, what am I looking for? So I'm looking for grams of sodium hydroxide. So I'm going to put equal sign grams of sodium hydroxide. The next step is what I'm given. Well, I'm given 2 things. I'm given the 100 milliliters and I'm given this conversion factor, this equivalence. Which one do I start with? Hopefully you remember just from a few slides ago, don't start with the molarity. Start with the other thing. So I'm going to start with 100 milliliters and put that over 1. So now I want to get rid of milliliters. So what do I know that will help me get rid of milliliters? Well, I don't have anything else in my problem that helps me get rid of milliliters, but I do know I also have something in the problem with liters. So I'm going to change milliliters to liters, and hopefully you remember this conversion, that there are 1,000 milliliters in 1 liter. And so now I've gotten rid of the milliliters. Now I have liters on the top, but I want grams. So now I want to get rid of the liters. Here's where this conversion factor comes in place. I have liters here. So I'm going to put that on the bottom and moles of sodium hydroxide on the top. So now milliliters cancel, liters cancel. I meant moles of sodium hydroxide. So I don't want moles, I want grams. So I now need to do another conversion factor. This time, what helps me go from moles to grams? Well, that's the periodic table. So I'm going to look up sodium, oxygen, and hydrogen and add them up together. And that gives me 39.997 grams of sodium hydroxide over 1 mole of sodium hydroxide. And I put the grams on top, the moles on the bottom, so they cancel. So milliliters cancel, liters cancel, moles of sodium hydroxide cancel. I get grams of sodium hydroxide. That's what I want. So now I just take out my calculator and do the math. 100 divided by 1,000 times 0.2 times 39.997. And I also remember to round to this has 4 sig figs. This doesn't count for sig figs. This only has 2 sig figs. This has 5 sig figs, so I can only have 2 in my answer. So I round my answer to 0.80 grams of sodium hydroxide. So there you have it. Just like all the other problems we've been working with, just as long as you know what to do with this capital M first. So let's try one more example. Here's example 2. How many milliliters of a 3.0 molar hydrochloric solution do you need to take to obtain 5.78 moles of hydrochloric acid? First thing I'm going to do is remember that this 3.00 molar really means that there are 3.00 moles of HCl equals 1 liter. And I'm going to actually write that down so I don't forget. Then I'm going to solve the problem like I solve all other unit analysis problems. First step, what am I looking for? I'm looking for milliliters. So I put equals milliliters. The next step is, what am I going to start with? I got 2 things, the 3 molar and the 5.78 moles. But the hint was don't start with the molar, so I'm going to start with the 5.78 moles of HCl over 1. Now I have to get rid of moles of HCl in the next step. I can use my conversion factor here and put the moles on the bottom. So then I use this information, put the moles on the bottom. Now the moles of HCl cancel and I'm at liters. Am I done? No, because I wanted milliliters. So what else do I have to look up? Hopefully, once again, you remember the conversion. There are 1,000 milliliters in 1 liter, and I put it so that the liters cancel, and I have milliliters on the top. So now all I have to do is take out my calculator, because moles cancel, liters cancel, I'm at milliliters, and do the math. 5.78 divided by 3 times 1,000. And that gives me 1,930 milliliters because I rounded that to 3 sig figs because there's 3 sig figs here, 3 sig figs here. This is a definition, so I don't worry about that. So I can only have 3 sig figs in my answer. Now, once again, example 1, I forgot to do the next step. So let me think about the next step. The next step is, does it make sense? Does it check? Yes, I checked the units. Does the number make sense? Well, this is about 6 divided by 3 is about 2. 2 times 1,000 is about 2,000. So yes, I should have an answer that's close to 2,000. So yes, the answer does make sense. So write these hints down. What am I going to do? You're going to change the capital M or the word molar or even the word molarity to an equivalence. How many moles of the chemical X equals 1 liter? Second hint, don't start with molarity. Don't start with a fraction unless your answer has units that are a fraction that have 2 components. And then we're going to solve, hint number 3 is we're going to solve it as usual using unit analysis. So hopefully that's all clear. We'll get a chance to practice them in class. See you then. Thanks for listening.